Hello, ladies and gentlemen. Welcome to Math 30-3, Chapter 7, Section 2, Cosine Law, Part 1. Now today, we're going to do two things. We're going to identify and describe the use of the cosine law in construction, industrial, commercial, and artistic applications. And we're going to solve a problem using the cosine law when the diagram is not given. So, how can you solve a triangle when you have two sides and the angle between them? SAS. Side, angle, side. Well, cosine adjacent over hypotenuse x over r, the adjacent. Now, this gets a little complicated, so I'm just going to gloss over. If it's not a right angle triangle, this is the version of the formula. It takes me too damn long to prove it, and honestly, you don't need to know. So, look very carefully. There's two versions of this on your formula sheet. This one, a squared equals b squared plus c squared minus 2bc cos of a. That's a cosine law looking for a side. If you're looking for an angle, we rewrite the formula like this. Cos of A equals B squared plus C squared minus A squared over 2BC. Now, both of these, I want to point out, side A or angle A, we don't know. All right, so calculate the length of side A. Now, here's angle A, 43 degrees. Side A is opposite it. Angle C is here. Side C is opposite that. Here's angle B, and side B is opposite that. Now we're looking for side A. So that's A squared equals B squared plus C squared minus 2BC cos of angle A. So plugging the numbers in. That is 7.9 squared plus 5.2 squared minus 2 times 7.9 times 5.2 times the cos of angle A, which is 43 degrees. Please make certain your calculator's in degree mode, please. That is 62.41 plus 27.04 minus 60.09. That equals, A squared. I should label this. 29.36, which makes A the square root 5.4. Now, I did that quickly. I don't expect you to be copying this out. I expect you to be looking at this and following along and understanding. If you want to copy it out, please hit pause. Copy it out. All right? Life is just too darn short. That's half of what I need you to be able to do. Well, almost half. Now, to make it half, side C. Find side C. Now, side C is opposite angle C. Side A is opposite angle A, and side B is opposite side B. Now, here's the problem. The formula is written A squared. All right? So it's A squared equals B squared plus C squared minus 2BC cos of A. So what I do is I relabel it. I'll call this side A. This becomes angle A. I'll make this side C, and this angle C, and this becomes side C. That way, I'm not rearranging to make this B squared equals A squared plus C squared. Too much, all right? So I rewrite it so it's the side I'm looking for. Now, plugging the numbers in. That's 35 squared plus 62 squared minus 2BC cos of 125 degrees. Now, my apologies, going too fast. That should be 2 times 35 times 62 times the cos of 125 degrees. So that is 1225. 62 squared is 3842. Now, careful. This is negative, but cos of 125 is negative. This becomes positive. 289.3. Check my math. So A squared is 7556.3, and A is the square root of that, 86.9. And once again, I'm doing it kind of quick. You should be following along. If you want to copy it out, pause the recording and copy, please. All right. Now, moving on. Oh, take a look at that. May 86. If this is 35, and this is 62, then this, yeah, that looks reasonable. Oh, yeah, poopy head to be, what was it, 86 or 87. Yeah, that's reasonable. Now, here moving on to find the angle. Now, I'm going to say this once nicely. I want to rewrite this so angle L is actually, I'm looking for angle A. So this becomes A. This is side A. Now, here I change them around, B and C. I don't care. I'm arbitrarily going to call this B. So this is side B. This is C. So this is side C. All right? Just rearranging it so it's angle A, I don't know. Or re-lettering it. Renumbering. Whatever. Now the formula is cos of A is B squared plus C squared minus A squared divided by 2BC. All right? I know, too many numbers. So, that is 7 squared, and, sorry, C is 3.6 squared, A is 5.3 squared, for 2 times 7 times 3.6. That is, sorry, cos of A is 12.96 plus 49 minus 28.09. All that's divided by 50.4. That's 33.87 by 50.4. And once again, if you are copying this out, pause the recording. All right? Excuse me, I'm not going to because life is too short and I want to get through this. Oh, you poopy head. Now, we plug that in. That is 0.6720. Now that's cos of A, right? I want angle A. Angle A is cosine minus 1 of that ratio, 0.6720, which works out to be 47.8 degrees. Now, I didn't say to the nearest degree. I didn't say to 1 decimal place, so I'm just going to go to 1 decimal place because I can. All right? Now, moving on. How big is angle T? Now, once again, I want to rewrite this. Call that A. So this is side A. Arbitrarily, I'm going to call this side B. Angle B makes this side B. I'll call this angle C, so this becomes side C. The only thing I care about is A, because it's minus A squared. The others I don't care about, so. Cos of A equals B squared plus C squared minus A squared over 2BC. And plugging numbers in. Oh dear, that's 165 squared plus 88 squared minus 116 squared divided by 2 times 165 times 88. That works out to be, wow, 27,225 plus 7744 minus 13,456. Well, that divided by 29,040. So, 165 squared is 27,225. 88 squared is 7,744, and so on. Now this becomes out to be 21,513 divided by 29,040, which is 0.7408. And once again, if I did it too fast, just, whatever. Pause the recording, copy it out. Now, that's cosine of A. That's the ratio. I want to figure out angle A. Well, that's cos to the minus 1, 0.7408, which is 42.2 degrees. Okay? Now, I'm going to pause the recording here because the video is getting kind of long. Once again, if I'm going too fast, just pause. Watch it again. Copy out what you need to know. Okay? Now, Any questions, shoot me an email. Otherwise, let's go on to the nasty one, and then we're done.